Welcome back to the Path of Longevity show, and I'm your host, Dr. Robert Lufkin, and I'm joined by my co-host, Dr. Steven Sidoroff.
Today, we get to cover a wide range of topics around the science and economics of infectious disease and aging. Our guest today is Dr. Tim Peterson, who's assistant professor at Washington University School of Medicine. His focus on longevity has led him to study metformin and rapamycin and the mTOR pathway, arguably the most validated longevity pathway known. We'll also hear about some innovative strategies using the blockchain to facilitate longevity drug development. And now, please enjoy this conversation with Dr. Tim Peterson. Hey, Tim, welcome to the program.
Hey, thanks for having me. I really appreciate it.
Yeah, so good to have you on this session today. And there's so many exciting things I want to talk to you about. But before we start, maybe you could just take a moment and tell us how you became so interested in longevity and kind of how you got to where you are today.
Yeah, so I've always been an athlete. That's maybe somewhat of a common way for people kind of get interested in their health. And then, through just training in school, I was in both MD and PhD programs. I just stuck with the PhD because I was so into being in the lab. And then particularly in longevity, we were studying the mTOR pathway, which is, one of the kind of more prominent pathways in longevity. But that was, I think it was in the early 2000s, early to mid 2000s. So it really wasn't, I don't think we really even knew that we were studying longevity. Like the first paper I was part of where we had aging in the title was like 2010. So I think it's kind of the first time where we were like, oh, we're actually studying aging here. So yeah, that was how I got into the space. And I think because I was studying mTOR, the drug rapamycin was, obviously always been key to that space. And so just really got interested into, drug development as a result of that. And so studied metformin and other drugs since that time. And so leveraged that to stay in academia. So I'm an assistant professor at Washington University, St. Louis School of Medicine. And but in the course of work there, have been able to launch two companies in this space, one Healthspan Technologies and the other one BioIO. The former is focusing on RNA therapeutics or making vaccines and gene therapies. And then the other one's BioIO is a small molecule company and focusing on it's kind of, we're taking a target ID approach. So
yeah. Before we dive in, maybe let's take a moment and tell us a little bit about how you look at aging and longevity. Why do we age? What causes it? Because everybody seems to have a little bit different view about this.
Definitely. So, I think the thing which really stuck with me is this kind of Gompertz law, where this thought that, essentially, right, aging and death is inevitable, and this kind of mathematical formula that the probability of death is exponential. And so the reason that was important to me is it comes from really, I think, how drug development is done these days and how I've realized drug development these days. So we'll often kind of go in with like, there's this whole rational drug design school of thought, right, where you have to know the target, and you have to hit the drug with hit the target with a highly specific drug, and that's really dominated a lot of that's all pharma right these days, and so I think that's largely not going to work because aging is this again, it's this inevitable thing. It's a exponential curve. And so exponents involve multiplication. So it's really at a kind of fundamental level, we have multiple things basically compounding upon each other to lead to our mortality. And so I think we're doing one, we're coming with one agent, even if it's mTOR, even if it's NAD or whatever. I think there's no chance that's going to work. And we see that with a lot of the drugs we come in, and they have a 10 or 20% effect, a lot of the cancer drugs and those kind of things, and diabetes drugs and whatever. And, 10 or 20% is not going to cut it. And so I really think we have to, so kind of the prevailing view that guides all, my company activity and my academic work is really thinking of how we can come in kind of with a multiplicative, I like to call them kind of multiplicative therapies, where you're putting multiple things together and they're having a synergistic effect to kind of do something important. And I think that really the fundamental example right now of that is this reprogramming, this Yamanaka cocktail of factors, right? It took 4 factors to do something profound, right? To reprogram a fibroblast or an embryonic cell, which could then go on and make every cell type. So I really think there's several companies in this space which are doing reprogramming. And the common thing there is they're taking, whether it's chemicals or mRNAs or whatever, they're coming in with multiple factors to do something important. And I think that's really the way drug development should progress. Because like even rapamycin, the very best case scenario we have right now, if you look in all the animal studies, it's a 10 or 20% lifespan extension effect. And then of course that will fall apart when it comes to humans. So where animals are all they're all the same, the genetically identical. So the variability there doesn't exist. And so that's how you can get these 10 or 20% lifespan extension effects. But in humans, right, we're diverse. And so those gains will be lost. And so, there'll be maybe some effects, I'm hopeful that Dudley Laming and others at, like University of Wisconsin will be, showing something valuable. But I think it's unlikely to be this kind of, escape velocity that people talk about where we're living, another 100 years or whatever. I think we're really going to need multiple therapies to do that. Things that are, highly synergistic and profoundly, affect our physiology.
Yeah, and so after having worked on rapamycin and metformin, you mentioned as well, I would assume you feel the same way about metformin, that it's a
metformin I think the data doesn't look as strong as that, and I think there's obviously it's a little bit like, well, it's not Democrat Republican, but it's a little bit like where people definitely have their horse. I think they're both really interesting drugs, mechanistically very interesting. The science is very cool. Both should kind of work. But I think it looks like the data on rapamycin is kind of clearly better. But again, I think both drugs are going to ultimately have a very marginal effect. As do most drugs. Even like we're still debating whether statins are useful or not, right? So I think again, these kind of single targeted agents, even in the best case scenario, are going to have some kind of marginal effect, equivocal effect. And so I really think we have to be moving outside that dogma. And the ALS drug that just recently came out, it has 2 components. I'm not sure that data will be much better, but it's, again, I think that's the start of the type of thinking we need to have. So.
Yeah. The idea of taking a single pill for, it doesn't work for chronic disease.
Exactly. Exactly. Most chronic disease are multifactorial, right? They're, polygenic, targeting one pathway. It's just the whack-a-mole thing, where you plug one hole and then, a new hole emerges, right? So, yeah.
Yeah, it's interesting. Well, the work you're doing on infectious disease and aging is interesting, because it's an area that is not often covered. So maybe you could just start off a little bit, and for the non-scientists in the audience, talk about some things like cell senescence, senolytics, and how those interact with pathogens, and how infectious disease is tied to longevity.
Yeah, so maybe I'll just, to backtrack with a very high level thought that, really our ability to fight off pathogens is how life expectancy has grown throughout human history, right? Of course, starting with like hygiene efforts, and then, sanitation, and then, antibiotics, and then vaccines. Really, if you want to look at life expectancy gains, it hasn't been through modern medicine. It's basically been through, very simple public health measures, and serendipity in the case of antibiotics, that we've been able to live longer, right? So and then you see now with COVID, right, come along and actually reduce the life expectancy in the US by a couple of years. It's clear that, that's a major drive. And now it's number, well, I think it's slightly behind heart disease, but it's, it's a major, now new cause of mortality. So I think we're just kind of ignoring the influence. There's just been not a really strong emphasis on infectious disease, and it's kind of baffling. I mean, I think it's, probably just, again, can't make money on it. It's not it's not some new fancy gene that somebody's making a drug to. There's just kind of a lot of reasons. Whereas like the Alzheimer's field, I think has been interesting, right? Because there's a lot of data emerging that pathogens, there's like a really cool Science Translational Medicine study that said that salmonella, the amyloid protein is basically, it's basically a trash man, essentially. It's like taking out, it's like fending off the pathogens that it's exposed to. So actually the thought that you'd want to be clearing the amyloid protein is like the exact opposite of what you'd want to be doing. Like it's actually trying to help, and so against pathogens that are oddly in our brain. And so I think there's there's just been kind of not a lot of it's just been ignored for reasons which are not clear. But of course now with COVID, I think people are and long COVID, I think people are more clued into the connections with infectious disease and aging. And then as far as like the senescence, so cell senescence is this concept where, over time, as our bodies, as we age, our bodies accumulate these cells which are senescent, so they're no longer dividing, like as opposed to like our stem cells, which kind of are dividing all the time and producing more, healthy cells that help us do, what our bodies do. The senescent cells are cells that essentially have stopped dividing, and they, instead of being helpful, they crank out a lot of cytokines and other kind of things that are essentially kind of dumping kind of toxic waste on our body. So, I mean, it's not totally accurate, but that's kind of the paradigm. And so there's many reasons why cells become senescent, but again, like a very kind of underappreciated reason is that, pathogens come along and, they kind of stress the cells. They're kind of they're just another stress, just like, UV damage or metabolic stress from, eating too much or whatever, or oncogene stress. Those things are more known. They're just, a big stress on the cell physiology, and that can lead to the senescence as a kind of a coping strategy to basically, not, I mean, it's really an anti-tumor mechanism to prevent, cells from kind of becoming, becoming tumors. So, but on the other hand, you don't get tumors, but then you get these senescent cells. And so, our work, we did some genome-wide screens and found some compounds which seem specifically useful in the context of pathogen-induced senescence. And so that's work we're doing at my company, BioIO. So and several initiatives there on those class of compounds. So.
Yeah, it's interesting the points you make that infectious disease is not just like getting sick with pneumonia and dying, but as you say, with Alzheimer's, P. gingivalis, or Lyme disease, mold, all these things that can give you dementia and essentially clinically identical Alzheimer's disease is fascinating. And you mentioned all the oncogenes. It's amazing the number of infectious diseases that can drive cancer that we're finding now that cancer can be transmitted with these infections and all. And it's almost like the infectious disease is closely linked with longevity, like you say, for the reasons with the senescence and all. And what's your take? I mean, as a rapamycin investigator with Joan Manick's work with the rapalogs and the immune, her classic work back then. I mean, just turning down mTOR, is that going to be, to dial down senescence with rapamycin or something else? Is that going to be the way?
I think it could be. I mean, I think it seems like the issue in talking to people, I've, been in the mTOR field for a long time, but I'm certainly no expert like, today. So it's from talking to the other experts, Dudley and others, it seems like, it's really going to be about the dose and, maybe some people, basically whether or not you're getting kind of immune protection versus immune suppression, I think, could be heavily dependent on the dose, how much rapamycin you're getting. And this drug is famously, highly potent, right? It binds at very high affinity through FKB12 to mTOR. And it's not a full inhibitor, but you just don't need much of it. I mean, it's really extremely potent. So, so I think hopefully we'll just be kind of microdosing rapamycin, and then maybe the rapalogs may work better. I'm not totally up to date with that, but you can imagine, of course, different rapalogs being kind of slightly better on the immune profile, slightly less on the metabolic liabilities. I think we're all going to start. I mean, I talk with this kind of multiple therapies where we come in with these combination therapies, reprogramming. Those are, of course, going to take a while. So I definitely am hopeful that, various rapamycin analogs will be kind of the first wave that will achieve kind of broad adoption. And I'd definitely be keen to try it. I mean, I'm not taking any of them currently or Metformin currently, but if, data came out and said, oh, as long as we keep the dose low, you get kind of all the benefits without, a low chance of the risk. It's hard to say. I mean, it's hard to say because, I think, I'm 45, and so it's like I'm healthy. I think the question is like, okay, do you start it when you're healthy? Do you start it when you start to kind of, some of your biomarkers start to go off a little bit? It's hard to know. I mean, I think it's I think it's going to be hard for all to figure out. So. Yeah.
I mean, what do you think the biomarkers will be for a drug like rapamycin? I mean, other than obvious, glucose going up that you don't want, but what are the biomarkers for longevity you think that are most promising? Because that's a big challenge, isn't it?
I know.
Taking any of these drugs.
Yeah, and like Nir Barzilai, right, is like he's trying to push the metformin TAME trial, and I think do multiple biomarkers, a lot of them kind of molecular. I'm pretty optimistic, having I have an Apple Watch and Apple iPhone, and the Apple Health app is really informative. I mean, it has all these gait measurements and has some heart rate variability. And those things definitely, so like over the last year or so, I've actually done, I really didn't do any strength training. And then over the last year or so, I mean, my gait has significantly improved. And even though I'm not like doing anything gait specific, I'm just doing, more kind of strength training. But I think that's kind of having some neuromuscular benefits that are, it's not saying I'm younger, but it is a measure, right? So I do think, I guess probably more digital things will come out, not just through, I know all the big tech companies are interested in that stuff. And of course, the other reason those are great is because they're consumer products. Like you don't have to go to the hospital, you don't have to do a blood draw. So I'm pretty bullish on digital biomarkers, whether the FDA will, approve them on some, time frame, probably doubtful. But I'm kind of bullish on the thought that a lot of the medical stuff will actually be probably not, I mean, it'll first come outside of the hospital system. I know like, it seems like Apple is really, and Amazon and stuff like this are really trying to make inroads in ways that probably we can't appreciate. And I do think like the hospital systems will be maybe the last to know. I mean, there'll be a lot of digital things that happen. And then, I think it'll be interesting to see how it plays out. The convergence of the tech and the digital health, the AI stuff, and then like the kind of bread and butter hospital based, molecular biomarkers and those types of things. I think there's going to be somewhat of a battle between those at some point. So did that make any sense? I'm not sure if that made sense.
It's more is better with the digital information. Hopefully the Apple Watch, the Google Watch will have the Raman Spectroscopy for the glucose.
Yeah.
I just saw a Chinese company that has a glucose monitoring watch for $100. I'm waiting for people to,
and I know like
how it works.
And like you can, optometry offices are getting these kind of retinal scanning it's not just for diabetic retinopathy, right? It can the quality of the visual quality of your retina can indicate all kinds of issues. I mean, and so people are working on the AI to do that prediction. And of course, it's just a snapshot of your eye, right? And so you don't, again, and having an optometry office, don't need anything. I mean, of course, you need the medical system if there's a real problem, but to do the initial kind of quick diagnosis, I do think a lot of it will move outside of the traditional system and there'll be more. Yeah. So we'll see.
There are probably mental markers for resilience, aren't there, Steve, that could play a role in that as well?
Well, it's interesting as you're talking about infectious disease and how you see that as playing an important role. And so from my perspective, stress plays a significant role in immune system functioning. Have you considered that aspect of it?
Definitely. I mean, I think I don't have any specific, like, there's not really any science, but certainly, I think, insults, stress, not sleeping and poor diets and other environmental stress, poor ventilation in your house, all those things are really, they're pretty basic, but at some level, a lot of people aren't, really aware that they need to manage those. Like, just from, like, I know it's just, you never, as a scientist, you don't want to be anecdote driven, but like I was, I was triple vaxxed, but then it got COVID. Fortunately, it was a very mild case, but basically it happened. I really don't know when my family got it. And I think I was the one who got it and like even had any symptoms because I hadn't slept like 3 nights in a row. Like, I had huge deadlines for work. And like that third night, I just was so worn out basically. And then I started to get the COVID symptoms and nobody in my family did. So again, just an anecdote, but I do think the stress, put me over into the symptomatic category. And I do think, just in general, those stresses compound.
Yeah, and we certainly see a growing percentage or number of people with chronic illnesses in our country.
Yep, for sure.
For sure. Just came across a paper this morning. We'll put it in the show notes, but it's about it's a large cohort of patients, and they looked at psychological stressors, and they calculated biological age, and the psychological stressors had a greater impact on biological age than the smoking history, than tobacco use, which was interesting. So we've got a lot to learn. Yeah. Oh, you saw that. Yeah.
Yeah, I know. I mean, I think that, they're just not, those types of things are not considered kind of first class, stressors, right? They're kind of like, oh, whatever. But I mean, it's, I think we do need more emphasis on those kind of things. Yeah.
Yeah, absolutely. Well, going from diagnosis back to therapy a little bit, could you talk a little bit about RNA therapeutics? What are they? What's the future hold? Where are we now?
Yeah. So there's a lot of amazing developments. Of course, the vaccine, was an mRNA-based strategy. So just if you're not familiar, the spike protein is a protein in the coronavirus that basically binds to the ACE2 protein on our cells, and that interaction is what's required to get the virus inside our cells and then cause all the damage. So the vaccine essentially is an mRNA to the spike protein, such that basically our bodies make the spike protein, and then our immune system, particularly the antibodies that get generated, can recognize that spike protein and then essentially block. So it's just the spike protein, not the virus itself. It's just the spike protein, and so it's a kind of a decoy to trigger our immune system to fight off the coronavirus. So it's not perfect, but it provides the filter that would allow us to, in many cases to survive being infected from coronavirus. So essentially the RNA approaches are ways to do kind of gene therapy. And I know, like, people get scared if you say it's gene therapy. In this case, it's like a viral protein. It's not one of our proteins that we're manipulating. But I mean, it's ultimately, what's so great about it is just because it's traditional drugs are usually like what we call small molecule drugs. And they're just teeny little things, much smaller than the proteins and things that they're trying to bind to. And so there's just a lack of specificity there. Whereas with RNA therapeutics or nucleic acid-based therapeutics, they're like the just specificity of the drug is much better. Yeah, again, the spike protein comes along, and the antibodies that get made to it are very selective just for that protein. They do nothing else in the body. So unlike a lot of the other drugs that we take, where they're kind of, non-specifically, blocking a lot of stuff, and so they're very kind of side effect prone. So I think the whole idea really came to fruition and came to the widespread public attention with the COVID vaccine. But there's been other efforts over the last, several decades, which also are really coming to head now. So Alnylam is a company that has siRNA-based therapeutics, I think mainly for cancer, but some other diseases as well. And so those strategies often are knocking down a gene. So there's a gene that's bad in some kind of disease context. And in this case, the siRNA is something that basically recognizes the normal RNA and downregulates that, the bad protein, and will downregulate that gene such that it's less likely to cause disease. There's other approaches involving CRISPR, which probably people have heard of, which is a gene editing approach. So you can deliver the CRISPR gene editing protein as an RNA, and it'll get made into a protein by our cells, and that's another very promising approach to kind of do very, very targeted therapy, much more targeted than any other therapy that existed. And then the other major component that has come to light is the fact, so that you have the RNA, and that needs to go in our cells and do something, but it can't just get into our cells easily. So it has to basically be surrounded by a lipid, essentially kind of a lipid particle, and that's there's been a lot of interest in how to design those lipids, and again, that field really, both the RNA and the lipid fields really came together very nicely with the COVID vaccine, and other people's of realizing that just put kind of peanut butter and jelly together, and you really can make a really great sandwich that is very specific and can do all kinds of things to help in ways that we haven't previously been able to do. So hopefully that wasn't too kind of
that's great methodology and great explanation of DNA and nucleic therapeutics. Now, I guess the follow-up question to that would be, given that technology, what are the targets for longevity that if you could, so let's say, knock down this gene or bind to a certain protein, how do you see it playing out for longevity then?
Yeah, so Turn Bio is a company that I'm part of this funding collective called Beta DAO, and we can get into that in a little bit. We help fund a company called Turn Bio, which is doing mRNA to the Yamanaka factors, which I mentioned earlier, these kind of 4 factors, which can reprogram cells from a fibroblast to an embryonic state. They're doing like what many people are doing, where there's kind of partial reprogramming, so just kind of like turning back the clock partially, not all the way to the embryonic state. So they're not only doing these 4 Yamanaka factors, which are like c-Myc, OCT4. I mean, I actually don't know if those are this is kind of private information, but I think many people are kind of focusing on these 4 factors, which Yamanaka got a Nobel Prize for: OCT4, KLF4, c-Myc, and can't remember the other one, SOX2 or something like this. But there's of course many others now that people have shown to be important, and so those are certain class of genes, ones that would kind of reprogram the cells to a younger state. I do think going after multiple pathways, kind of the canonical pathways, autophagy pathways, mTOR pathway, that can also be helpful. I think people just have to see. We're I mean, there's just a lot of kind of well-known pathways, and I think probably your best bet is to go after some of the kind of core targets of those pathways. So I mean, like
rapamycin, unlike metformin, is a very clean drug. It's very highly targeted to mTOR. What advantage would obviously there are a lot of advantages, but if mTOR works effectively, if rapamycin works effectively for mTOR, then you'd want to do a similar thing to like upregulate AMP kinase or other sensing, nutrient sensing, longevity related proteins. Is that what you're thinking?
Yeah, I think so. I think it's so rapamycin is really interesting because it again, I mentioned earlier, it kind of partially inhibits mTOR, so it's an allosteric inhibitor, so it's not plugging the active site of the kinase, so it's not going to just like kind of uniformly downregulate the mTOR pathway. It kind of has some specificity, but which part of the pathway hits more so than others. So if you were to downregulate mTOR using an siRNA approach or some kind of nucleic acid approach, it would, it may still function similar to rapamycin, but it may have different kind of kinetics or different kind of target profile. So, I'm not totally clear. I mean, it's still the issue with the nucleic acid therapies, even though I said like the lipids come along and, that's a really nice delivery vehicle. It's still not as easy to get the kind of broad distribution, not nearly as easy to get the broad like cellular distribution and body distribution as you get with small molecules, which are small and can kind of diffuse throughout the body easily. So maybe mTOR is not the best target again, because like you just mentioned, there's already a drug for this, and it's kind of like everyone's already making good progress there. But I mean, other pathways, certainly be fair game. I mean, the way it's going right now with the nucleic acid therapies is really going after kind of monogenic diseases like sickle cell anemia. There was a CRISPR trial. I guess that wasn't necessarily, I think that wasn't an RNA approach, but nonetheless, people are going after single monogenic diseases where, you fix this one mutation, you downregulate this one protein, and it like has the desired effect. Longevity may not be the first, probably it's already not the first basically use case, because it's, chronic diseases are just, harder to fix. And, so I think it'll be a while before you figure out the cocktail of things that will work. But TurnBio is pretty far along. I mean, they're and other companies are kind of on their heels. So I do think it won't be too long. So for longevity or more kind of chronic disease applications. So.
Well, speaking of TurnBio, and you mentioned this a little bit before, we've got so many things so many fascinating topics to cover. And I wanted to make sure we talked about VitaDAO and what's a decentralized autonomous organization, and how is it helping in longevity drug discovery and other areas?
Yeah, so I mean, I think what's interesting about, a lot of people, when you hear the word crypto or decentralized or blockchain, all those things, people kind of are skeptical, right? A lot of people are skeptical, and I actually think there's a lot of people in the longevity field feel like we're kind of outsiders as well, right? I mean, you can't actually, I'm an academic at a university, and you can't really use the word longevity. You have to use the word aging, right? Like longevity sounds a little bit too like snake oil, right? Or certainly like anti-aging you can't use, right? And crypto is the same thing. I think it's this field which is providing an alternative. Most of us argue it's like a more fair money system, right, where it's outside of the government control and anyone can do it, right? It's peer-to-peer. And so I think the longevity and crypto communities really have a alignment around we're kind of outsiders and not taken seriously by the mainstream folks. And so that's was part of the basis for forming VitaDAO. And essentially we're a funding collective. So the DAO, decentralized autonomous organization, we're not like registered in Delaware, or it lives on the Ethereum blockchain. So it's like it lives in the metaverse. So again, it's a new kind of concept. And people, like I said, it's a collective where people put their money together and to fund research, and it's a nonprofit. So meaning like any kind of profits that would come out of any drugs that you develop, you just put back into the treasury to fund more research. So it's not it's intentionally not trying to be something that would be a for-profit company. And the other thing too is we have a token. So a token helps us basically govern the way to make the decisions on what gets funded. So it's called the Vita token, and you can get it on various exchanges. And the idea is, ownership in that token allows you to say to kind of chart the course of how we spend the money. And so to me, that's a really exciting way. It's a democratized way. And what's really cool, compared to having been in the traditional academic system and the traditional way of doing things for many years, is really you just get people of all different perspectives. A lot of people in the kind of crypto world are anonymous, and so you don't know who they are. They don't know what their credentials are. So it really makes a much more kind of flat structure. And I think you really have to kind of listen to people's arguments. so for example, what's been really interesting. So Pfizer has just contributed funds to VitaDAO recently. There was a big announcement on that, and so we have representatives from Pfizer in our organization, and they're coming in with their traditional approach, and people like me push back and say, okay, well, this is how Pfizer does it, and but we're not necessarily operating that way, right? So I think it's been interesting to see, but they also have value perspective. It's like, well, okay, you can be a dreamer, you can propose you're gonna cure these diseases with these crazy strategies, but there is this kind of business reality or kind of scientific reality that we need to live in. So it's been fun to kind of have those worlds collide, and I think again, where one is not clearly better than the other one, and I think that's leading to some better outcomes and better conversation, because just again, it's not a hierarchical driven system. So
yeah, I like the idea you said that VitaDAO is not a registered Delaware C Corp or anything. It's a nonprofit, but is it registered as a legal presence at all? So it doesn't exist within our legal framework because it's entirely running on smart contracts and
exactly
in the crypto space, which is fascinating. It's it's amazing that you've been able to do this. And what are the advantages with this over traditional drug development, and what are the challenges? Obviously, Pfizer's interested, and they're becoming a part of it, which is wonderful. So how is this going to succeed where other drug projects fail that are driven by purely for profit for Pfizer, let's say?
Yeah, so I mean, I think we're able to do kind of different experiments, right? I mean, I think that's maybe one way. I mean, we'll see. I mean, time will tell, of course. But I think one thing, because people are coming with different ideas, we're able to act in a different way. And so, like, for example, we funded a film, which is hopefully going to be on Netflix soon, where it's just about longevity, telling kind of the story of longevity and how people are doing biohacking, and it's really kind of an awareness piece. So kind of definitely media marketing, stuff like that is I think it's important to our mission. And so that's not something Pfizer would do, right? They would not fund a film, right? That's not something that a traditional biotech VC would do. So I think we realize the power of is creating awareness around what we're doing, and ultimately all the big tech companies are all media companies. They're not only doing R&D, but they're getting the message out. So I think awareness is a huge part of what we're doing. We're actually in talks to create a journal, an academic journal, and that's another way we can kind of establish legitimacy. Given the intimate connection between publishing and funding. The funding drives the publishing, and then kind of feeds back on itself. So I think we got to be involved in both those activities and gain legitimacy in those areas. So I think there's many things we can do that are kind of outside. It's certainly not a biotech VC firm. I mean, we can take on many different things that will help sustain the organization, hopefully. So.
And just to be clear, you're actually going to be developing intellectual property that would be licensed as NFTs, non-fungible tokens, and so it can actually profit and sustain itself and the investors and the patients that participate. And
definitely.
The other thing I wanted to underscore, especially for this audience in this program, people are listening to this because they're interested in longevity for themselves or their families. They want to understand it. And VitaDAO is a way to actually participate in it. So any person can go, with a little knowledge, if with cryptocurrency, they can purchase VitaDAO tokens. And by purchasing tokens, they become part of the VitaDAO community and can vote on drug development and can participate fully as a member of it. So it's really a unique thing that the cryptocurrency makes possible, the true democratization of research and science and knowledge. It's really fascinating. And
thanks. And I think several of us in what we're calling the DeSci community, decentralized science community, several of us are interested in this concept that token wouldn't only be kind of a governance token and voting on things. We would actually be, potentially gating access to medicines. That doesn't sound right, but essentially it would be, the token would do more, and have much more utility for people, give them access to, discounts on supplements, things where, it would, yeah, like I said, the simplest thing is to, like, give the token much more utility as to why you'd want to, be part of the community, and deliver a lot more value for both sides, for the people who own the tokens, as well as for VitaDAO and other DeSci organizations. So I think you can definitely, currently it's, just voting. That's not, maybe that's great, and we're excited about that. But I think we have many more ideas in the future about how to make, crypto much more of an active participation. So I think that's, that's really what we're excited about. So.
And I think VitaDAO is the leading organization of this type in the longevity space. Are there other organizations in other science and healthcare similar to VitaDAO that this is rolling out now?
Definitely, yeah. So Molecule is an organization based out of Switzerland that's helping launch DAOs. So there's LabDAO, there's SciDAO, there's AthenaDAO. So LabDAO is kind of a general purpose, at least currently computational, dry lab focused, kind of general purpose infrastructure DAO, lab infrastructure DAO. SciDAO is for psychedelic research. AthenaDAO is for women's health issues. There's other longevity ones, the 9 Lives DAO. There may maybe a few other more fledgling ones that are emerging. 9 Lives is for, I think, for cat. The idea that probably we can get to human health if we focus on our pets first. People love their pets. There's Loyal, the company Loyal, which is focusing on dogs, which has gotten a pretty good amount of traction. So I think it's a great strategy. So I think definitely, I think it's definitely the other part about being, a nonprofit, and just, I think in general, people don't really preach about crypto. There's definitely more of a, we're all working together vibe. And there's actually this kind of acronym, WAGMI, we're all going to make it. So like, people just really, it's much more of a kind of collaborative environment than, the traditional biotech world. So.
Yeah, that's exciting. Well, we just have a little bit of time left, maybe 1 or 2 questions I'd love to ask you. Other than the things we've covered, what are 1 or 2 of the most exciting areas of longevity right now that we haven't talked about?
That I'm not working on, right? You said.
Yeah, well, you mentioned the Yamanaka factors and the partial epigenetic reprogramming.
Exactly. Yep.
Yeah.
So that's one. I think that we're not working on. There's I think the pets idea is great. I think the pets idea is, focusing on the pet. even if your goal is to just help pets, that's actually great too. But the idea that, you can get to market faster, you can prove things, certainly on, I think that's a great strategy. I do think I kind of already said this earlier, the digital health stuff, where, we have like one project that I'm trying to get off the ground. I just think digital health is, there's this kind of famous, Mark Andreessen quote, software is eating the world, right? And I think that, I kind of already said this, but, the medical kind of establishment, which I've been a long part of, all my family's in, in medicine and doctors and all this stuff. I just think they're kind of a little bit asleep at the wheel of what's going to happen with software. I think software in general is going to, take over healthcare, just as, it takes over every field. So that's probably the biggest area where I don't have enough of our efforts that I would like to spend more time. So, and I think everyone who's working in that space is, I'm cheering them on. So,
yeah. Well, one more take-home thing for people, if everyone listening, if they could do one thing to improve their longevity, what would you pick to start with?
Well, actually, probably the one thing that maybe people wouldn't say, and though maybe a less common answer, I do think the social interactions, I think it's underappreciated how much, how human, how much basically our kind of psychosocial well-being influences our body physiology. I have a colleague. How much time we have? Or we need
like 10 minutes. Yeah.
Oh, 10 weeks of time. Okay. So I have a colleague, old colleague of mine that's at NYU, Bradley Miller, who like I'm embarrassed to say I didn't know stuff like this, but he showed this video where mice came together. He had a serotonin, like a real-time serotonin reporter, and he had a bunch of mice, and as soon as they walked together, their brains just lit up with serotonin. And I just never forgot that video, because it just shows that, we need to be together physically, to be, for our health. And it's just basic biology, basically. And so I do think we definitely need diet and exercise and those things, but I do think, human connections are, just very underrated. So
I appreciate you bringing that up, because it's a major component of resilience.
Yep.
Social interaction, what I refer to as emotional nourishment.
Mm-hmm. Yep.
That's a very important aspect of mental health, and I think it will turn out to be a very important part of longevity.
Definitely. Yeah. Definitely.
Yeah, there's just another paper out about that, how emotional loneliness is a risk factor for all these chronic diseases and ultimately longevity. And their take-home message was, make friends, have a partner if you have a partner. If you're in politics, get a dog, but get something, but make that connection, even if it's with an animal, with a pet, but
definitely
do that. Yeah. Well, Tim, how can people reach you on social media? What's the best way for people to follow you?
Yeah, so I have a fairly generic name, so I insert my middle initial in there. So I'm Tim R. Peterson pretty much everywhere. I think my LinkedIn is actually kind of the opposite. It's Peterson Tim R. But kind of always, like I said, I include that kind of R middle initial to stand out a little bit. Like Stephen A. Smith is like the famous like sportscaster guy on ESPN, and also generic name guy, but puts that A in there, and so at least know it's him. My companies are, like I said, are Healthspan Technologies, healthspan.dev, bioio.tech. That's the bioio.tech is not live currently, but we'll have that live soon. Social media, like I said, everything on social media and stuff is just Tim R. Peterson. And that's my emails as well, bioio.tech. And you can reach me. Anyway, many ways. So
sounds good. We'll make sure people know about all of those ways of connecting.
Thanks. Appreciate it.
Thanks so much for being on the program, Tim, and we appreciate the work you're doing, and we'll look for you on VitaDAO also. Let's say hi.
Thank you.
Definitely. Thanks. Grateful.
This is for general information and educational purposes only, and it's not intended to constitute or substitute for medical advice or counseling, the practice of medicine, or the provision of healthcare, or diagnosis, or treatment, or the creation of a physician-patient or clinical relationship. The use of this information is at their own user's risk. If you find this to be on the value, please hit that like button to subscribe to support the work that we do on this channel. And we take your suggestions and advice very seriously, so please let us know what you'd like to see on this channel. Thanks for watching, and we hope to see you next time.